Hello, welcome. Let's see another example for one-sided hypothesis. Let's see for the public swimming pool, we have seen that we are testing the concentration of a specific antiseptic material. So our initial assumption that the average concentration should be at least 740 million. So we are afraid that the mean value of this concentration will be less than 740 parts per million. So our null hypothesis is mu equals 740. Our alternative hypothesis is mu is less than 740. So this is considered as one-sided test. So now we have got a sample from different position or different locations from the swimming pool. We have taken 40 times testing or 40 elements. So we have checked the swimming pool, for example, 40 times at random manner or from different places from the swimming pool. And in the 40 times we have calculated the concentration of the specific antiseptic material. Also we have summarized the sample mean or the average to be 739.2 parts per million. Also here in our hypothesis we are lucky to know the population standard deviation or the variance. So we have the sigma to be known, for example sigma equal 4. This is given or known value. We will also use the same confidence level to be 95%, and we have alpha value to be 0.05. So now we continue. So now here we have the acceptance region, this white area, to be 95%, and the rejection region is 5% now to the left side of the normal distribution. So the rejection area is to the left side because in the alternative hypothesis we have a mu less than 740. We have this critical value of z to be minus 1.645. In the past we had this to the right here, which was 1.645. We know that the normal distribution is even and symmetric around the 0, so this will be the same value but in minus or negative. So now we have the same methodologies to compute z0. Z0 we have x bar value, the sample mean, minus the hypothesized mean, which is mu, divided by sigma. We have sigma which is equal 4, and square root of n is square root of 40, which is the sample size. So we calculate to find z0 is minus 1.26. We have the critical value of z1 minus alpha to be minus 1.645. This value is called z1 minus alpha because the area to the right of this value is 1 minus alpha. So 1 minus alpha is 95%, and alpha is 5%. So area to the right is 1 minus alpha. So this value is called z1 minus alpha. We have z0 equal minus 1.26. So we notice that the z0 lies in the white region. So the white region is the acceptance region, the blue region is the rejection region. Now because z0 is larger than z of 1 minus alpha, we fail to reject the null. Or we say that z0 is larger than minus z alpha, also we fail to reject the null. In fact, minus z alpha is the same as z1 minus alpha, as we have said, because the normal distribution is even and symmetric around the 0 here for the standard normal distribution. So now what does it mean that we fail to reject the null? We fail to reject the null. This means the mean value of the antiseptic concentration stay at the safe level, which is 740 part per million. So now we have used the test statistics Z0. Also we can use the confidence intervals to check and examine our hypothesis. We will use one-sided interval. We will use the same methodology, but now we have mu to be less than some value, which is the same analogy we have used in the one-sided test or two-sided test. So we know that Z0 at this equation, we know that mu is less than this. Okay, now we calculate the confidence interval. So the confidence interval is mu to be less than 740.42. So now this is the upper limit of mu, and the mu value can be any values from this value until minus infinity, but in fact we know that it will reach only to 0 because there is no concentration below 0. So now we look for the mu naught. Is mu naught included or belong to the confidence interval? Yes, because the mu naught is included. So the mu naught is less than, in fact, this value. The mu naught is 740.0. So mu naught is included in the confidence interval. Thus, we fail to reject the null hypothesis. Also, we can use the methodology of the p-value. Now we have the Z0 equal minus 1.26. So now Z0 is indicated by the red line here. So what is the p-value? In our case, which have the alternative hypothesis as mu is less than mu naught, we have the p-value is the total area under the curve from the red line until minus infinity. So the area under the curve from minus infinity until the red line, which is the Z0 value, will be the p-value. So if we use the cumulative distribution function, this will be directly as phi of Z0. So we can get the p-value as phi, or cumulative distribution function at value Z0. From the standard normal distribution table, we get the p-value to be 0.103. So how to use the p-value? As we have said always, we will reject the null only and only if the p-value is less than alpha. But how much is alpha? Alpha is 0.05 or 5%. So now we are going to fail to reject the null at alpha equals 5% because the p-value is larger than alpha. So finally we fail also to reject the null hypothesis.